Sorry, I stole someone else's.
Those don't say
I was like looking at it, was like, we haven't actually started yet.
Do you know who I am?
Well, we just looked at that.
Yeah, well, you're saying that.
We have a pretty good agenda. Are we spending any time going over draft issues or anything? We have to. And so I should pull up.
Oh, and look, it's Mr. Nice. We appreciate the confidence you're showing in the newer chairs.
I was enjoying my first RSUP meeting.
Good afternoon, everybody, and welcome to day 2 of Httpbis. Would somebody in the back row mind just closing the door to the hallway? That always makes it much easier to hear what's going on. All right. No, wrong presentation. While the chairs get going here, I'll ask again if someone in the back row could close the door to the hallway. That'll make it a little easier for us to hear. Thank you. That's awesome. I appreciate it. We've already got a note taker. Thank you, Piotr. And we've also got a JavaScribe. Thank you, Julian. So got our act together at least to get going here. Today is a little more diverse than our first meeting of the week. We're going to talk about a number of, you can go ahead and well, all of our adopted work, or almost all of our adopted work, and the progress that is making, as well as some information on proposed work and items of interest. So we'll be moving through the agenda fairly quickly. We're pretty full up. Here's the note. Well, talks about the rules under which your participation in the IETF rather are. No, the IETF, that's just me slipping up a little bit, are governed. If you got questions about this stuff, it actually is pretty important. Feel free to talk to your chairs or any AD. I guess Alexi is with us today instead of Barry because of scheduling conflicts. We got all that. Here's our agenda. Hopefully these drafts look familiar to you and you have read them. Variants, BCP 56bis, which is in an interesting state. The cache header, client hints, header structure, secondary certs. We'll have a great update from Mike Bishop on the HTTP3 work and how that's going with Quick. And then 1, 2, 3, 4, 5 proposals and sort of FYIs. So as we talk about the adopted drafts, we'll also probably talk about open issues in the effort to move those drafts forward.
That's it.
That's it. So variants. Mark, are you going to speak to variants?
Yes.
Would you like the issues?
Now that's a microphone.
Would you like the issues and stuff?
Yes, please. How far away can I stand? Is that still? Wow. That's a good mic. Hello? Okay. About here, I think. Okay. So so variants is fairly quiet. The two main kind of areas, if you look at the issues list, I think there's a few issues, a number opened by Jeffrey Yeskin. Jeffrey, are you here? Yes, you are. Hello. You're very yellow again. It's very easy to find you. So the main consumer for a lot of the feedback we've had from variants is actually the web packaging work. They're using variants as a way to talk about the selection of the representations in the package, as I understand it. And so Jeffrey's been giving good feedback, and for me, it's really good confirmation that variant seems to actually work for their use case, which means that as a mechanism, it kind of works. I'm also still talking to implementers. Fastly is talking about it internally, although I don't have any commitments to make there, of course. And I've had a long-running conversation and needling of Leif Hedstrom from Apache Traffic Server. Leif, are you in the room? Here. Oh, okay. Still at lunch. Wise man. He's looking at prototyping it in a module. Because the way modules work in ATS, it probably won't be a full implementation, but at least give a proof of concept to see how it runs. I won't go into the issues here. I just once again encourage people to review it, to implement it if you so feel inclined, so we can get some more feedback. For me, the only big thing in mind about this spec is its nature, that to work with a particular content negotiation mechanism, so a header, request header, response header pair, you need to define an algorithm in a spec somewhere and have that implemented in the cache for it to work. Otherwise, you fall back to vary behavior. That's the trade-off we made. The first attempt at this was the key header, if you remember that. And in key, you actually embedded that algorithm into the header, in this little constrained language. And we decided that was horribly complex and hard to implement because it made potentially unbounded CPU on the cache, and error-prone because authors had to get that algorithm exactly right when they produced the header. So that's why we moved to the variant approach. There's still a little doubt in the back of my head, so I'd love to talk to folks if they share that doubt, or they don't. That's it for variants, unless people have questions. There's Leif. Your ears were burning. Leif, do you have any feedback or announcements on variants?
Nothing new. I like it.
It likes you too.
This is Roy Fielding. Why is it that variance key exists as opposed to just reading the header fields that are in the representation?
Because the key can diverge from the contents of the header field.
Okay, well, we'll talk about that.
I'm happy to talk about that offline because I need to work through a worked example. And if you want to raise an issue, we'll do it there.
Do you want to? Okay. Next on our list, thank you, Mark, is BCP 56bis. So don't sit down.
Right. BCP 56bis, we think we're done. It is part waiting for HTTP core to be done so that it can reference it. That causes a little consternation by some, but that's what we've decided. I probably will do another editorial pass through the document and make sure that it still makes sense at some point. And if people have additional things that they want to talk about, I think we probably could do that if we needed to. It's not hard closed. It's just kind of soft closed.
Yeah, I like to consider it closed pending. The consensus was it was closed pending, those references. But
maybe not.
It's not published, so
yeah,
it's easier than updating an RFC for sure. Ted.
Ted Hardy. This is not the same kind of microphone you have up front. So this is just something that kind of came up during the discussions around using DNS over HTTPS. One of the pieces of advice in the BCP 56bis is that one of the ways of disambiguating an application that is not the web, that uses HTTP as a substrate, is using a media type, which is what the DNS over HTTP essentially does, because it uses the UDP wire format of the DNS as kind of a key part of its.
Sorry, could you say it's not part of the web if it uses the media type? I'm confused.
I'm saying you use an application-specific media type to indicate that it is not the standard browser interface that's using HTTP. So it's already in the document, right?
That sounds very odd. I don't think the document says that.
Okay, let me read it aloud.
Yeah, we can put it on screen if that would help. Just give us a section.
Just a second.
Big. Maybe full screen. I don't know.
Are you reading from BCP 56bis or DOE?
BCP 56bis. My one-handed typing is very poor.
Take pictures now.
Thank you, Nils, for your service to the community.
Is it me or is this thing flickering? It's horrible.
Especially when you look over.
Yeah. You see how the corner of your eye, and you're just like,
So in 4.1.2, coexisting with web browsers on the second page, using an application-specific media type in the content type header and requiring clients to fail if it is not used.
sorry, which paragraph is this?
It's the first
Okay.
one on page 21.
Right. Okay. So that's if you don't want web browsers to interpret things as generic content, then use an application-specific content type.
Exactly. And
Yes.
so I think this is great advice. I was just going to suggest that we also add something into the security and privacy considerations that say, what that does mean, though, is if you have a proxy or something else that's capable of seeing this application-specific media type, it becomes a fingerprinting point to allow them to know which of these applications you're using. Since it's not a generic content type, it is a application-specific media type.
Right. But we also encourage people to use HTTPS.
Absolutely, but it becomes something which is leaked to a proxy.
So there's an underlying issue there, which has come up in another context, which I think we'll probably talk about later, which is a proxy that's acting on behalf of the origin server, for example, part of your threat model. And then what does that mean?
So in particular for the privacy section, all I'm suggesting is that it note that when you use one of these application-specific media types, anything that's a proxy along the path, be it on behalf of the end user or the origin server, will thereby know which one of these applications is using the HTTP substrate.
I'm going to push back on that a little bit, because I think that what you're really saying is that if you don't encrypt data, anything on the path can see that data. That's true for the URI, it's true for the headers, it's true for the body. MIME sniffing is now well documented and widely implemented, so even if you use a generic media type, they can still understand what application you're using.
Oh, if folks don't agree, I won't stand at the microphone any longer. I think it would be valuable, but if I'm the only one who does, that's that.
No other comments? Okay, we can move on. Mark, don't sit down, but then you get a break after this.
What's next?
The response, the cache response.
Okay, so open issues. I think this is largely done as a spec. I think I probably need to do 1 or 2 more iterations on it, and I think we need to get some people prototyping with it. The 2 issues we have open, 778 cache header name. There's a proposal at 777. I think this is a byte shed. I don't really care. I chose cache because people use Xcache most widely right now, and that seems to be the most direct translation of what we're doing. On the other hand, we are going to propose proxy status a little later on, and maybe it makes sense to align them if we do choose to adopt that.
Alessandro, Cloudflare. Using cache doesn't seem particularly consistent with other existing headers like cache control. So that was mainly where this came from. And again, proxy status as well. Yeah.
Can we just hum or something? I don't. Either way.
I mean, I'm hesitant to hum if there are no opinions. Does anyone have an opinion, even if they don't want to stand up? Raise your hand if you have an opinion of any kind. But Mark is also willing to stand up.
Martin Thompson. This is a bike shed. That is my opinion.
Yeah. That's, okay. We'll figure out a way to do it. There may be coins involved.
So generally, in the past, we've said that editors have some degree of discretion when it comes to naming things.
Right.
I think that's true here.
Some degree of discretion, but we want this consistent with the rest of the
Sure,
architecture.
and I think that sort of input is always appropriate. And if, Mark, you're willing to wait for people to get experience deploying this thing, then maybe you can also wait for the other thing to come to the point where it's a little more mature, and then you'll have a little bit more information.
Sure.
I know it's a little awkward when you have to go out and deploy some things without a name, but
Sure. That's harder.
just preempt it.
It's easy to
put something in.
it's easy to get people to prototype it when they think they're not going to have to do much work after that.
Renaming a header field is really not high on the list.
Might be surprised.
Terrible.
I foresee an even numbered design team coming. I'm sure that's going to work out well.
Sure. I will chat with Alessandro offline and see if we can figure this out.
I think
Next,
that's the right way to do it.
unless Julian wants to join us. Alex's feedback, 766. So this is, I think, just some feedback from the very long-running experience that Squid has had with these issues. And I think it makes sense to incorporate these as probably new parameters on the header design. So in like a collapsed parameter. And the refresh one, I want to look, I think we already addressed that, but I'll double check that. Does any other cache vendors have any opinions about this? And indeed, if we have other cache vendors, if you want to add new parameters to indicate different states, let's have that conversation pretty soon. Leif. Okay, I think we'll take that offline. Thank you.
Great.
Am I done?
Thanks, Mark. Yeah. Right. Next, we have client hints. I think Yoav is going to come up and give the presentation. No? Yes. Excellent. Got 15 minutes for this, including discussion.
Don't. Back up. Not that far. Okay. Here, that works.
Okay. Hi, so I'm Yoav. I work on Chrome and here to present on client hints. I'm gonna explain a bit what the framework is, what it does, and what hints can potentially use it, and then we'll discuss it a bit. So essentially, the mechanism that we're talking about is a privacy-preserving proactive content negotiation. That's a lot of P's. It's based on a server opt-in, which means that by default, requests contain no information. So this does not add and potentially reduce passive fingerprinting. It's only over secure connections, so that would prevent MITMs from extracting that information and increase preventing surveillance situations. Same origin only, so this is more of a web concern, but it basically prevents unauthorized fingerprinting by third parties when the first party origin enables those hints. And at the same time, in order to enable some of the use cases, we do permit cross-origin delegations. So a first-party origin can delegate the hints to certain third-party origins, which have a legitimate use of that information. The opt-in mechanisms are a couple of server response headers. One of them is accept.ch, a header that provides a list of tokens for the various hints, the various features that the server is interested in getting information about. And the other is accept.ch lifetime, which gives a number of milliseconds for which that opt-in should be preserved for that origin. So that enables client hints over over future navigation requests. The third-party delegation mechanism is basically, like I said, client hints are sent only to first party to the same origin by default when the opt-in is delivered over the top-level navigation response. Which prevents us from leaking information through passive resources. A previous concern with the proposal was that if a page includes image resources, those image resources would get that information even though they cannot theoretically run JavaScript in order to extract it by other means. So in order to tackle that, we introduced a delegation mechanism that is using feature policy, and a feature policy header can be used to tell the browser that a particular host should get a particular hint. So for example, enable a viewport width and DPR delegation to image CDNs. That's the main use case that we had in mind. A potentially contentious part here is that we want to add a sec prefix to all the hints. We want to do that in order to reduce the chances of hitting legacy server bugs. We want to avoid coarse preflights at all costs because they're not good for you. So we want to be able to safely send client hints to servers. So we want to avoid any kind of legacy bugs. We want to be able to guarantee more certainty to servers who process these headers, to, knowing that the browser generated those headers gives you some guarantees versus any random JavaScript developer on the web, even though you shouldn't necessarily rely on that because browsers can also be malicious, but it's still better. And a small side effect of that is that it may enable simpler processing in fetch. So that was potentially true last week. I'm actually not sure that it's true. We had discussions since. I'm not sure that it's still provides simpler processing, but the main arguments here are the first ones. We want to not send cores and be sure that we're doing the right thing. Okay, so there are various features that rely on that infrastructure. I divided them into improved content negotiation, which we have image-related hints that are defined as part of HTML, or are supposed to be defined as part of HTML once the PR land. And we have a bunch of network-related hints, which are defined in netinfo, in the netinfo specification. So RTT, downlink, effective connection type, and we potentially may want to spin off save data into its own specification because it's slightly different, and we've heard some interest from people who want to implement save data but not the other network related hints. All of this is currently shipped in Chromium. The third-party delegation mechanism is not currently shipped, but it's being worked on. So hopefully we'll ship soon. Can you go on? Okay. And we have a couple of features that we want to use in order to reduce passive fingerprinting surface on the web. So currently the user agent header and accept language are headers that contain multiple bits of information. They are sent with every request on the web to every server that is interested or not. And we want to make it stop. So we plan to replace those mechanisms, or start by supplementing those mechanisms with the client hints that enable deliberate access to the same amount of information, but one that requires a server opt-in. And then hopefully over time, as compat permits, deprecate or freeze the passive fingerprinting vectors. This is currently implemented in Chromium, but not yet shipped. And changes to the draft since the last time we presented is that we removed the image-specific hints that were part of the IETF draft and moved them to the HTML PR. We did that both to have better processing models defined for those, as well as reduce confusion between the hints infrastructure and the features that are using it, because theoretically, browsers could implement the infrastructure, but not implement the image-related hints if they choose not to. We have a PR up in the air to add a sec prefix, or at least a sec prefix recommendation. And I also wrote down, because the current specification is split between the IETF draft, HTML PRs, fetch PRs, and other specifications, I wrote an explainer and a document that kind of ties it all together for people who want to review the current situation without clicking through a million of tabs. Okay. And essentially, we are looking for more implementers and more implementer interest. We currently have running code in Chromium as well as in various servers, and one particular image CDN that we work with is Cloudinary. And we want more browsers to implement in order for us to be able to move forward the IETF draft, in order to land the PRs, and most importantly, in order to improve user privacy, performance, and experience on the web. So with that, questions?
Do we have an issues list? If there's, I would like to offer a thank you for writing the guide to where to find all this information. That's a very useful thing.
Yeah. Martin Thompson, the guide is helpful. It's the first time I've seen it. So I didn't realize there was so many different moving parts here. We have some reservations about the use of feature policy generally. I know that Arne van Kesteren's talking to Ian Cleland about this one routinely. Our input has been that there are aspects of the feature policy stuff that are not very mature, which might be, and some of them that we don't necessarily agree with. This is spread over such a wide amount of different places that it's very hard to follow. So if we go working group last call on this one, it's going to be difficult to make any sort of real assessment about how it all fits together. But this was my concern, and this document that you got in front of me, now I have at least a hope. So thanks for doing that.
Okay, sure. Regarding the feature policy, I know that there are some concerns about the inheritability of feature policies to nested context. And in the context of client hints, to be honest, I think it would be fine either way, whether the frames inherit that or not, or inherit that without opting in as themselves or not, would both be, from my perspective, both solutions would be fine. So
So only having seen this for the first time today, and I didn't realize you were doing feature policy until you mentioned it on the slides here, it does seem to fit fairly well with the use of feature policy that we imagine is most directly useful in the short term. Unfortunately, we have some reservations about how that policy is expressed and managed and so forth, and the way that the other aspects of feature policy then sort of bleed into this, making it a lot more difficult to make progress here. That's probably feedback for the feature policy people as much as it is here. I would say that you could probably move forward with this and the other pieces of this, modulo the concerns about the fact that I haven't read all of it, without the feature policy part, and simply say that it doesn't delegate into third-party contexts until you work out the feature policy part, and then progress that independently. I think that would be perfectly reasonable. Maybe not as functional, or as useful, but certainly something you could do.
Okay, thank you.
Tommy Polly, Apple, and as an individual. So yeah, thanks again for the clarifications on this. So we had discussed before, and you made a comment about saved data being a little bit different. From our perspective, I think at this point we're interested in being able to mark saved data. At this point, I don't think we are necessarily planning on doing anything with the other hints. We do have some reservations. But thank you again for presenting this. We'll definitely go and review that more. Can you clarify just exactly what your plan would be for a separated out saved data? Just how do you imagine that working?
I imagine it to be a separate graph that just mentions saved data without, like, basically spitting it out from the current network info API into its own independent draft, so that folks would feel free to implement that and not implement the other network-related hints.
Cool. Thank you. And actually, just kind of from an editorial standpoint, then it may be good to mention what things make sense as client hints or not. I think from like the network info perspective, a lot of those things are saying, oh, this is my RTT, this is other properties of the network. The saved data seems like a different category because it's probably more of a user opt-in. And so giving a rubric for people extending this in the future to say, these are the type of things that make sense as hints would be great.
Okay, thank you.
So Mark, yeah, this mic is different. Mark Nottingham. So with my Fastly hat on, I've talked to our image optimizer team, and they're interested in this. It's exciting to get that granularity of data and to be able to automatically optimize images for websites that are our customers. So yeah, please continue. With no particular hat on, I would encourage folks to look at this document that we're talking about in this working group as a framework for new content negotiation mechanisms. And I would hope that we would not require all new content negotiation mechanisms to use it, but there'd be a lot of encouragement that this is a good pattern. Let's find the right pattern for this, document it, and then kind of beat the bushes towards that in the future. I think that's your intent, and I just want to get confirmation there.
Yeah.
Okay, great, thanks.
I'm going to soft cut the line, which means if you want to speak, get up right now.
Yeah, Eric Scola. Not like, I guess, I'm not sure I agree with the characterization that this reduces the fingerprinting surface. Changing some of the things that are currently sent in rich headers into client hints obviously does, but the problem is you're also adding things which that would not otherwise be accessible to the server versus memory.
So each one of those hints is also coupled with a JavaScript API. So browsers.
I'm not sure I should feel better about that.
Basically, this is not adding any new information that a website cannot conclude from a JavaScript API. So it's, in a sense, identical to currently existing active fingerprinting vectors that browsers can track, block, lie about, or somehow penalize usage of, but doesn't add any passive vectors, if that makes sense.
I suppose that's no, it's not. That's not true. Because it adds passive vectors because otherwise they had to call a JavaScript API. So if something that was previously accessible via JavaScript API and now it is sent by the client all the time, that is changing an active vector into a passive vector.
That is not sent all the time. It is only sent on a server opt-in. So
yeah, but
only
it's sent every request to that server once the server is requested.
Where the server can do the same with cookies or can do the same with the URL declaration for third-party delegation.
Yes, I am aware of that fact, but that's interesting fingerprinting and state storage. And given the browser specifically taking action to restrict state storage, that's not a very persuasive argument.
So I don't think that the current mechanism doesn't expose any new vectors. So a website can
takes active vectors and makes them passive vectors.
It is not passive vectors because it requires a server opt-in. So an opt-in would make it active.
Once again, there's a difference between something which the server has to explicitly do and something which is sent with every request. And so one of the things that we look at in order to determine whether or not, excuse me.
So, Mark, the line was cut, Mark.
One of the things we look at in order to determine whether or not certain activities by servers are fingerprinting is to determine whether they're making requests for data which they do not appear to make any legitimate use of on the client side. And so So for instance, WebRTC. And so what happens is they ask for an array of things, which then get sent to the server, and we have no way of knowing how the server processes them. That actually does form a kind of passive fingerprinting vector, which is a different set of properties than the JavaScript APIs.
How is that different from site reading that data into, like, using JavaScript and adding it to cookies or adding it to URL query parameters?
As I said, browsers are taking actions to restrict the use of state storage.
So browsers can take very similar activity against the usage of those client hints for websites that collect many bits of information. So browsers can keep track of which sites collect which bits. And in this case, tracking client hints will not be more complex or less complex than tracking the equivalent JavaScript APIs.
I don't think that's accurate for the reasons I indicated. The fact is, we can tell when the site is actually attempting to make use of the data, and as opposed to when they're just shipping it back for storage. But when it's being sent over, when it's being sent, and if they are stuffing a cookie, that is something that's potentially abusive. But in this case, when the site asks for it and then sends it back to itself, we have no way of knowing how that is being used, and so that's a different situation.
How is that different from sending viewport with NDPR to the server?
Yeah, and if it's regularly doing that and not apparently making any use of it, that is something which we would look at.
The apparently making use of it is the same, like it would be identical for client
So,
hints
gentlemen,
and query parameters.
This seems like we're going in
Yeah,
circles.
apparently you and I disagree about this fact.
I think
Okay,
this
let's
is-
talk about this more
Yeah.
afterwards.
this is coming up fairly often
Yeah.
from different folks.
Yes.
And I think there are a number of people who feel that there's an equivalence here and other people who disagree. So it seems like we need an issue just about that. And we need to find a way to get resolution, probably pulling in the appropriate people
Sure.
from different places.
Yeah,
So
I guess-
let's go ahead and do that.
Okay.
Sure. I guess my question would be, has any other web engine indicated they're going to implement this feature?
Not at the moment. No.
That was my impression.
And to be clear, that's not necessarily a bar for us publishing.
It is not a formal bar in the way it is in what working group. However,
Yes.
one of the questions I want to ask when asking whether something has consensus in advance is it going to be implemented?
Yeah.
And if it's being implemented primarily by one client, that is a strong indication saying perhaps should not advance.
Yes, but there's a history in this working group of still doing that. So we'll take it as a case-by-case thing.
Hi, Robin Marks. I just wanted to say the idea of splitting the safe data header into a separate spec seems very good to me. As we talked about before, I see a future where we also have more specific user preferences, not just a generic safe data, but actually users saying, I want this type of content or I don't want this type of content for this URL. So that would make that easier in the future to work with. So please do that.
Okay.
Alan Frindell. Clarification question about the server sent response headers. Is it intended that those will be sent on every response from the server, or it only needs to go like once per origin?
They are respected only when coming in on responses from a top-level navigation response. And so if the server is not sending an accept CH lifetime and it's only interested in hints on sub-resources, it can send, like, it needs to send them on every navigation response. If the server is interested in having those hints be applicable to future navigation requests, then it needs to add an accept CH lifetime, and for that lifetime, it doesn't need to opt in again, even though it could.
Okay. My motivation for the question is if this does become part of the standard, I'm wondering if we should have these headers included in the QPAC static table or not.
I didn't hear that.
Should we add these headers to the QPAC static table or not?
Yeah.
Yoav, thank you for your time. That was educational.
Thank you.
I mean, are we going to discuss any issues?
Oh, you want to? Yeah.
We are already over time on this. I'm concerned about the rest of the agenda. Is there an issue that we think we could make progress on?
Maybe discuss the sec prefix, because you had, I don't know.
You don't seem too excited about
I'm just, yeah, I haven't really given a ton of thought of which issues we need to discuss here and which we don't. So, but this seems like the
By my
one that-
math, we're 10 minutes behind on the agenda, so we can just, I think, move on. Yeah.
Okay.
All right. So,
Okay.
thank you.
Okay, thank you.
I assume Paul Henning, I didn't see him on Meet Echo. Were you going to do this, Mark?
Yes. Yeah. So structured headers is, I think, nearing completion. We have a few issues open, which we need to work through. I'll go through a couple of them very briefly, and then I think the meaty one is the last one, 737. So Roy just opened 782, define a URI reference type. I think we kind of informally considered this before and didn't see a lot of interest, but it doesn't cost a lot to add. So my only concern here is that what's, how strict are we going to be about the URI reference syntax inside of the brackets? If, there's this tension between the formal definition of URIs and what browsers often allow inside URIs for things like location. And if we specify something that's very strict, will that strictness be maintained, or will we have interoperability issues as some people loosen it up? Roy, to the microphone.
So this is Roy. While I agree that's a concern, I think it's a concern regardless of whether they're represented in angle brackets or double quotes. So I don't think you've addressed that kind of concern anywhere else in the spec. It's just,
Sure.
yeah.
Sure.
This is just a way of distinguishing them from quoted strings.
It's just there's a fairly strong practice of using sloppy, let's call them sloppy URLs. There's a fairly strong practice of using them elsewhere, but I'm not against trying here. I think the worst possible outcome would be that we specify it and it gets implemented, but some people implement it badly, and then this is an area of the spec that you can't use because there's poor interop, or that you have to use with kid gloves or whatever. But that's not to say it's not worth trying.
Right. And to be clear, I mean, it would be okay if we had sloppy reference in there instead of URI reference.
Okay.
Now, what I would define as a reference today is sloppy reference.
I'm really hoping this term's going to stick now. Thank you.
I was
All
hoping the
right,
opposite.
I'm happy to add that, I think. Next one, 781, empty list and empty field values. I think this is, we constrained the syntax of things like lists to require at least one item back when we were being really strict about a lot of things. I could see an argument to allow empty lists. The only thing being that, if I remember, there have been issues in the past where you have headers with empty values that are stripped by some implementations. I don't know how widespread that is, but I think it does happen. And if I remember, there have been cases where we've decided that it's a best practice not to use a header with an empty value because of that. And I think maybe that's why we require at least one item.
Roy again. I can understand that as a theoretical concept, but I don't. If we're going to have structured header fields, and keep in mind, I still don't believe we actually need this at all.
This being
so
what?
The structured header field specification, because there actually is a generic parsing syntax for HTTP. It's just that we don't declare it. But if we have one, I want it to actually make some progress and not reduce the amount of things that you can define. The accept header field, for example, has meaning when it's sent empty.
See.
So it's, I understand why people may be concerned about that, but having a structured header field syntax standard for HTTP, which cannot represent common HTTP, doesn't make any sense to me.
So the goal of this is to be somewhat compatible with common HTTP, but more to have a crisp data model for new headers, especially. People in the past have said, why don't we have null here? And I think that's an interesting question. My response off the cuff was that we don't see anybody using null in existing headers, but I'm happy to be proven wrong for that. For empty lists, you characterize it as a theoretical concern. I think it's a very practical one. It's that it won't work in certain circumstances. It sounds like you want it to be theoretically complete in allowing empty sets, which I understand, and I sympathize with. It's just in the current syntax that won't work on the wire in some circumstances, as far as we're aware. Having said all of that, I'm happy to open up the syntax and just put a warning there if other people think that this is important. I see Kazuho nodding his head. Anybody else have any opinions? Who cares about this? Julian cares. Anybody else? Julian, do you agree with Roy? Just point at Roy if you agree with Roy. He agrees with Roy. Okay. All right, let's open it up and see what happens. But I do want to put a warning there that if you have an empty list in your syntax, it may get lost along the way.
Kazuho, would you like to point at someone?
You're pointing at the sky. Okay, thank you. Okay, let's do that. If you could record that, or someone could record that in the issue so I don't forget, that'd be good. Next. Parameters is a set. I noticed, oh, I'm so descriptive. Yeah. Yay me. If I remember correctly, I think that this actually is...
Significance of ordering.
Sorry? Yes. That we have, right now parameters are a set when there's a question of whether you want to be able to preserve ordering there because dictionaries are an ordered dictionary. We added that a while back because it seemed like there was half-decent implementation support for it, and there were definitely use cases for it. So I think the actual request here is to turn parameters into an ordered dictionary rather than an unordered dictionary. I don't know why I called it set. Does that make sense to folks? Because I found a use case for it. I forget what it was. We're at the cutting edge here.
Well, it's Roy again. If I remember correctly, the variance key is actually using an ordered set.
Yeah, but that's an ordered dictionary. It's an ordered.
It's a list.
Yeah, well, that's a list. Yeah, no. So dictionaries are They're an ordered dictionary, and because parameters on a parameterized item are modeled as a dictionary. There's a dissonance because dictionaries are ordered and parameters are not. And what I think we want to do here is make parameters an ordered dictionary as well. And I see a thumbs up.
Jeffrey Eskin. And Jeffrey Eskin, yes. I assume that in a spec that wants to treat them as a set, we would just say that explicitly in the spec instead of relying on the structured headers definition.
Sorry, the word here, set here, is a distraction.
Sorry. In
an ordered dictionary?
In a spec that doesn't care, that wants to treat all orders as equivalent,
Yes.
it would just say that.
Yes, it would need to say that, yes. Yeah. And we should probably have a hook for that.
Oh, Watson Lad, I just have a clarifying question. So you want this to become a list with no repetitions allowed?
No, it would be an ordered dictionary, which is a data structure that is being surfaced in more and more languages.
So that's a list with keys and values, and you can't repeat a key twice.
That would be one representation of it, yes.
Okay.
Yes.
Is Martin Thompson, is it true that you can't repeat a key?
That I think, and again, I was so descriptive when I raised this issue. I think that is maybe the nub, is whether that is going to be, maybe that's why I said set. That would be the trade-off, that you can't have a repeating key.
Is that true for the dictionaries as well?
For dictionaries, it is true, yes.
Okay. Well, as long as the two are consistent, I think the principle of least surprise dictates that they'd be consistent. So go ahead.
Okay. I think that's enough guidance on my incredibly vague issue. Thank you.
You should write that down.
Sure. Yeah, please, for the love of God, somebody write that down. So this is the fun one, integer limits. One of our implementers, our hardworking implementers, noticed that implementing structure headers in JavaScript was tricky because integers in yeah. I'm not done yet, Murray, because integers in JavaScript have a constrained range. See, there's a lot more here. And so we went back and forth on it for quite some time. It's very wise getting to the microphone now, Kazuho. And we kind of came to a point where I made a proposal that we constrain the value space. And remember, structured headers, there's an abstract model, and then there's a serialization in the HTTP 1.1 headers and textual headers. And my proposal, if I remember correctly, was to constrain the value space to roughly -2 to the 52 to +2 to the 52 with, I think, a small delta, which I'm sure I'll be corrected upon momentarily. And that was the minimum that implementations were required to support, but they could support numbers outside that range if they so chose. That was the minimum footprint for interoperability, which is the same approach we've taken on most of our other headers. For example, we say lists must have, implementations must support lists with at least foo members, and I think foo is 100,024 if I remember correctly. And so that seemed to gain some support. And then PHK came along and made a different proposal, which was, I love the reaction to the phrase, then PHK came along. He made a proposal that we limit the syntax to a number of digits, a number of characters first, and then you parse it, and then you have an integer. And so then I believe the number that he proposed was 15 after you take the sign off. And so the practical effect of that is that our abstract value range is fixed. It can't be or greater if your implementation so chooses, and it is smaller than 2 to the 52. It's because you need to chop a digit off effectively. And so we went back and forth on that. And if you scroll to the very last message here, I think so the PR allows up to 19 digits. If you support that many, whereas his supports 15 digits. And so it's a trade-off. And I think the trade-off, if I understand the arguments being made, is that by constraining the number of digits and failing if it's more than 15, and then parsing it as an integer, we actually get more reliable behavior. We're not throwing it into an integer parser and then hoping that that works in a way we understand, and then constraining that result. We're doing it the other way around. And so it's more predictable. And I like that property. That's a good property. The PHK makes another argument, which is that it's easier for implementers to get the range right because it's not 2 to the 52, it's just a bunch of 9s, which I personally find a little bit weak, but hey, whatever. And then the other argument is that I think he says you're not going to need that extended range, which is where I wanted to probe people and see if they felt. I think that PHK's proposal makes sense. I just wanted to get feedback from everybody that they understand what we're getting into here, that the integer type in structured headers is going to be a fixed range, and that if people need numbers bigger than that, they're going to have to do something else, like stick it in a string or a binary, or come up with a new structured header type, which might be completely okay. But I just want to make sure that this is with our eyes open. So.
As a whole, actually, my understanding was that PHK argued for having minimum guaranteed range of 15 digits. And I think that resolves the concern that you have on the last comment, that bigger numbers need to have a different type. So to me, it seems that the discussion that shifted from the 52-bit approach to the 15-digit approach was just about selecting the minimum guaranteed range.
I didn't get that at all from the conversation. My understanding was that he wants to clamp the number of digits and generate an error if you exceed it as a way to make sure that whatever you feed in the parser is what we think it is. I think you do a filtering for non-digit characters, number of digits, and then if that all passes, then you're good to go to feed it into a parser. If you don't clamp it to 15 digits, you don't get that property. And then I think really the only difference is can an implementer type in a bunch of 9s more reliably than they can type in the digits that form to the 52. And I really don't find that compelling.
Well, my view is that allowing implementations to clamp and then pass helps them not implement vulnerabilities. That was my read. But
Sorry, I didn't understand that.
Well, so
a little closer to the microphone. Sorry.
Sure, allowing implementations to clamp to first check the number of digits and then passing it. allows it to reduce the chance of having vulnerabilities, and thereby making the minimum guaranteed range to 15 characters. Makes sense, even when you allow implementations to exceed that range, knowing that it might have interoperability issues.
I see. So you're saying minimum guaranteed range is 15 digits. Implementations can choose to clamp at a larger number of digits if they know that they can handle that.
Yes.
But that's an implementation decision.
Sure.
Would there be a max on that?
No.
Wow. I think I can live with that, but okay. Let's see what other people think.
So, Martin Thompson, the reason we put numbers in header fields is usually to count things. And like 15 digits is a lot of things, yeah. And we do have limits in other protocols that sort of are in that general size category. Now, it is in theory possible even in a protocol like Quick to exceed this number in terms of just counting bytes, or if you want to count bits, you can count bits. Milliseconds, nanoseconds, you get a pretty long way with 15 digits. And I'm perfectly comfortable in following PHK's suggestion here, because I think that anyone who needs anything more than that, I think they can probably get by with the string hack or the different type hack or any of these other things. And this is pretty straightforward.
Right.
We do have floating point, or did we cut that? I think we don't have floating point, do we?
Sorry? We have
don't
floats.
We have floats?
Yeah.
Yeah, we'll have that debate separately then.
Sure.
But I think that's,
okay.
If you want to go really big, sometimes you might need precision on that. But if you're talking, financial things, good luck to you if you got a number that big, by the way. Then you're going to have to build special data structures for it, and you're going to know that you're going to need to build special data structures for it. And so I'm perfectly comfortable with it. I don't mind Kazuo's suggestion and sort of naturally sort of start there, but then when you think about it, I can't think of a use within this. Byte ranges that reach this large. Good luck.
So my reaction to Kazuo's proposal is nervousness, because I think interop might suffer in places that matter. And yeah, so just a concrete example, if you are running over Quick and you want to represent a stream identifier, you can't do it with an integer here. And I think I'm okay with that too. Like I said, you can come up with a big int if you want later on.
We're going to soft cut the line here, so get up if you want to talk now.
Brian Sniffen, my concern here is that if the limit is there, some people will lazily build parsers that just parse whatever JavaScript naturally represents. And so there will be some messages that are interpreted in some place as an int that doesn't fit in this, and some places as a string. And so that's going to get complicated and then eventually exciting.
So have you read the SH spec?
Not in sufficient detail.
Okay, so this is the wonderful thing we're trying to do with SHs is we really, 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 really mean it that you be strict in parsing. And so all the parsing is specified by algorithm, and we have a test suite to prove that people actually follow the algorithms. Yes, it is a bit of a game of chicken. Somebody might go out there and create the permissive structured header parser, and then we will live in that world.
One has a test suite and specifies the algorithms for parsing also.
I know. Thanks for that nightmare.
This is Roy again. I just have a meta comment that the idea, as I understood it originally, was to simplify the processing of HTTP message handlers by giving them a more regular grammar. I do not, in any circumstances, understand why you would need this kind of data in a header field. Now, I could understand having large numbers. I can understand having binary values. I can understand having UTF-8. Very large strings of digits doesn't make any sense to me whatsoever, because there's a point at which just put it in base 64. Otherwise, you're spending 200 characters. I mean, obviously, people don't read these numbers, so what?
It sounds like you're agreeing with the PHK approach then. Okay. No, not 60. It's a 15 characters, not 64 bits.
Like Mark mentioned, if you just happen to have 2 to the 61 or so quick streams and you wanted to identify them, you won't be able to. Oh well. When you think about what it takes to get 2 to the 61, or in the order of 2 to the 61 streams into a quick connection, you'll realize that you run out of packet numbers, and so it's kind of academic.
Well, in a way, but if I define a field that is supposed, if I define a header field that's supposed to be able to represent a quick stream ID, it would be weird not to allow it to represent the entire range.
Sure. It's weird.
So I just use something else.
All right.
Maybe, if you really do care about that sort of thing, yes.
I think we're done.
We're going to have to move forward.
I think we're done. Okay, that is very good input. Thank you so much.
Mike, you're going to be up next with sort of the quick and HTTP3 update. No? Did I miss it? Oh, I missed secondary search. That is my fault. But Mike will be speaking on the topic, so that's convenient. Julian?
Can I make a final comment about the structured headers?
You mean after the line was cut? No.
Yeah, I thought.
So there's some folks who joined
for the
us late. If you could circulate the blue sheets, that would be great. Go ahead, Mike.
Okay. All right. So if we can recap from the last couple IETFs, we've had an ongoing discussion about ways in which secondary certs make things a little bit easier to attack. And there are 2 different scenarios that we care about. One is the misissued cert problem, where you've been able to, the attacker has been able to induce a CA to issue a certificate with your host name on it, and then can go and get somebody to connect to them thinking that they're actually connecting to you. And the other one is that you get a legitimate cert and it's compromised and it's easier to use because you can go deploy it on your site and send it over secondary certs so long as you have the appropriate private key. So when we're up, can we stay on that one for a second? So when we're talking about what you need to do, in both of these cases, if you want to pick up attack traffic, you have to be able to subvert either IP routing or DNS resolution in the normal case. And we're trying not to create that situation with secondary search. We don't want to make the problem worse and make it easier for attackers. Next slide. So this is a simplification of an approach that we presented last time. And I've taken Nick's suggestion to get rid of the affiliated domain property and just go with requires. So that is sufficient for, if you're on a CDN, then the client, each customer of the CDN says that it requires the CDN, and the CDN will have to issue a cert that requires whatever the primary domain is. And if you want to bind a whole set of certificates together, you designate some sacrificial domain that you put in all of your certs, and you require that from all of the certs, and any of them are acceptable. So next slide. This is what it looks like on a CDN, where the CDN has to have some kind of a bridge cert that can require whatever the primary cert was, and then that's the thing that all of the secondary certs that it's going to present from other customers hinge off of. So we talked about this last time. This seemed generally acceptable, but it has one major failing, next slide, which is that it really only fixes one of the 2 problems we were talking about. If you have a compromised certificate that's legitimate, the certificate was originally issued as saying it is only able to be used on my CDN. Somebody compromises it, gets that private key. They still can't use it as a secondary cert anywhere else because it's bound to that CDN. And if they bring it back to that CDN, presumably they will notice that they have a second customer presenting a certificate for the same domain and alert someone that that might be an issue. So the problem that we don't have a solution for yet is what happens with misissued certs, where If the attacker is able to get the CA to sign anything they want, they can put anything they want in the certificate, and nothing we define to be added to the certificate can stop them. Next slide. So remember, the problem that we're trying to deal with is this is an induced navigation. Now you don't have to put the attacker's domain in the same cert. So when you do a certificate transparency check, you will eventually find that misissued cert for your domain, and you don't have the breadcrumb to say who it actually belongs to. I see you shaking your head.
Just go to the microphone, no problem.
Watson, I worked with, I don't think I understand the issue with misissuance. I'll explain at length later, but finish presentation.
Okay. So the issue here is that without secondary certs, if somebody were to go and misissue a cert that jointly covered victim.com and attacker.com, and they could get you to click on a link to attacker.com, then the owner of victim.com would be checking CT logs for things that reference their domain, find that cert, and have it revoked. Now, the difficulty with secondary certs is you no longer have to put attacker.com in the misissued victim.com cert. So you haven't really changed the outcome. You're still going to get the cert revoked, but you no longer have a clue. Now, that clue might be next to useless because they will hopefully be putting a throwaway, well, hopefully, they will most likely be putting a throwaway domain in the cert. So I don't know how much value there actually is there, but it is a reduction in security. But comparing, next slide, comparing the case with misissued certs where we're saying, oh, well, this is removing the breadcrumbs, to the other problem that we're concerned about where you have a compromised certificate and we say the problem is that you're going from you have to be able to subvert IP routing to and all the attacker has to do is an induced navigation. Well, we already had that problem. We agreed that that was okay when we did RFC 8336, which is origin. So fundamentally, I feel like the working group is coming at cross opinions with this. And either we meant it in 8336 that this is not a problem. So let's solve the compromised certificate issue with the PR that we already have and move on. Or we now think that this is a problem and we think that we are maybe reversing ourselves from 8336 or we need some other kind of guarantee there, in which case let's fix it both places. So next slide. I think we need to have a discussion about we have two axes here of do we have to have clues about the bad actor and do we need anything other than there exists a legitimate cert? And if their cert is there, it's okay because it will get revoked soon enough if it was misissued or compromised.
I'm just trying to think through the defense you're proposing for the first defense you're proposing.
Sure.
Can you go back to the slide, please? Sorry.
A couple more.
Yes. No, even better. Good. Okay. So as I understand it, the way this works is that when I want a secondary cert, it's got to have the trivial version. It's got to have it lists the name of some primary cert, which has to be previously displayed, right?
That has to already be proven on the connection.
Exactly. Yes. Right. Yeah. And that if this is intended to defend against this, this is intended to defend against the scenario where the certificate is stolen, right?
Yes.
Okay. And so the concept here is that that certificate is it presumably I have to hijack the DNS for that certificate because I mean when I break into the CDN and I steal like the secondary cert, I steal all the certs, right? I steal all the private keys, right? So I got them all. But the assumption is that I would have to have gone to the DNS for the primary, right?
Whatever the DNS is for the primary, yes. You would have to control that.
Okay.
And two, compromising the CDN is not the only way you could have gotten that cert if it was one that the client had issued themselves and then given to the CDN.
Sure. Okay, I'm gonna have to think this through a little bit.
Okay. So, see, I don't remember if I have further. Okay, yeah. So we have the two discussions here of focusing on just the compromised cert. Are we, third IETF, having basically the same proposal? Are we comfortable that for that problem, this is the right solution, or do we have other things that we should do instead? And for the compromised cert case, for the misissued cert case, do we have other questions here of exactly how we want to handle this? I've heard some suggestions in hallway conversations this week. Maybe we want to require a CAA record to bind you to a particular CA so that you reduce the scope of your misissue. And I see that bringing lots of people to the mic, so.
Actually, before we go there, I want to ask, this is Nick Sullivan, Cloudflare. I want to go back to the slide where you have required star, and I'd like to ask whether or not required star bypasses this ability to track down a stolen certificate, or it having required star. When it comes to misissuance, though, if we didn't allow require star, we could, and we required an actual domain name, then we actually would have a breadcrumb for misissuance.
That is true. So, which is on one of my other slides where I have the axes, one of the points is if we care about this, reduce the scope of a wildcard in the requirement.
Okay. All right. So yeah, I just want to clarify that point. And then the other piece is, yes, as you suggested, there are, for some types of certificates, such as signed exchanges, additional requirements to validate something in the CAA record so that it's much more difficult to misissue. I think that might be a potential helpful situation here for any certificate that has a requires in it.
Yeah. And one thing that I know you had suggested before, and I forgot to mention, was putting a CA verification requirement that to have a requires extension in your cert, the CA has checked the CAA record.
So Martin Thompson, I like the CAA thing as a belt and suspenders and glue option here. I think that the simplification that we're looking for, and this is already a lot simpler than what we saw in Bangkok. The simplification is to take that requires star option away and have it. You have cdn.com in customer1.com certificate, and therefore everyone else can just point to that. I'm not sure what the star is providing based on a second look at this one.
So what it's providing is for the cases where customers bring their own certs. Speaking for Akamai, we're not going to let a customer put Akamai on their cert. We're not going to let a customer have a cert.
That's the concern there. Yeah, it's the BYO cert.
Yes.
Issue problem. Yeah.
So then basically the trade-off you're making is if you can't have a require star, then the CDN will have to issue a separate certificate for each customer.
Right. That may actually be okay, but I think we'd have to ask the CDN folks whether this is a deal breaker. But that particular one is probably something we could work with. The other thing I was going to get up to suggest was that if we have a CAA record, that CAA record can actually include cdn.com in it, so that when the CA verifies and issues a certificate for that domain, it can look at the CAA record and only ever issue something for cdn.com or what have you. And that might be even more glue and maybe nails this time.
So I have to admit, I haven't looked at the syntax of CAA closely enough. Okay, it's just text. Okay.
Watson Ladd here from Cloudflare. I'm a bit concerned with the fact that we're looking at misissuance and saying that, well, if there's a misissued cert, we have no indication of what's going on. And this is very surprising to me. I thought CAs had to keep records of all their issuances and explain why they issued the certs. And if they couldn't provide those records and there was a problem, then the ban hammer falls on them. And so I'm just a little confused by the misissuance thread. It seems to be going around that, we need more evidence, and of course more evidence is nice, but we should already have reams of evidence. The CAA should already be checking CAA records.
Yes, they should.
And if they're not, then that's a problem that needs to be fixed in the BRs.
So I think what I hear you saying is, don't worry that much about misissuance because there's already enough data.
No, I think what I'm saying is worry about misissuance, and if it's an extreme worry here, then there are bigger problems out there because IP routing is not at the state that is not great. DNS redirection. So those are things, yes, it makes the bar a little lower, but there's already bad stuff going on.
Okay.
So Martin Thompson, one of the principles that we used with doing this misissuance thing is not so much worrying about those sorts of problems. Yes, people can hijack BGP and they can do DNS things, but the key here is understanding that there are a lot of these records that are produced, and yes, everyone is auditing these things, but they can only audit those things to the extent that they are auditing those things, and the people doing the auditing might not have any more information that's relevant to the particular scenario than the person who was issuing the certificate in the first place. And so the reason that you want that, one of the principles driving this is saying, well, if I'm the owner of a domain, I can look at the CT logs and get alerts for things that I would generate it, and I'm really the only one who knows that I have requested a certificate be issued for that name. And if something appears that doesn't appear in your database, you can then take action. And so there's layers of defense that we're talking about here. And I think this is probably why we don't want to have things like the requires star in here too often. And we probably want to have some rather extraordinary circumstances under which that is issued, because it removes that breadcrumb trail that you're talking about.
Right. It's an explicit opt-in that I think I can keep good control of my certs. And
Okay.
I'm willing to take that risk.
Actor's going to get the last comment in this round, but we're going to look at some issues, so we're not done with secondary search. If you have something to say.
I'm sorry. I'm just like, I didn't get much sleep last night, so I'm probably just super dumb. But I read this PR again, and I'm like watching the presentation, but I'm still like a little confused. I think I understand what the mechanism is. But like so I'm like I want my I'm going to get my certificate hosted by like some CDN, right? I'm going to get my site hosted by some CDN. So I get a certificate, and what the behavior I want is that that they went to the CDN to visit Mozilla.com, and then they make and then they can make a request for like RTFM.com, right? That's the behavior I want. But like as I understand, I mean, unless I'm missing something, like the set of domains they come in on is like randomly distributed, and the set of domains they want is like randomly distributed, which means that like I just don't understand like how I don't end up with require star all the time. Are they supposed to? Is there some other secondary certificate that they hinge through the always? Okay, so the idea is that I'm supposed to say my thing Cloudflare.com, and then when the and then to enable secondary search, like they come in on Mozilla, then they secondary search Cloudflare, and then finally the secondary search RTFM. That's the idea it's supposed to be. So then I don't understand why you need the star, because it seems like the CDN can just publish the name of that damn thing.
Well, where the star would come in is in the CDN cert. If you don't allow star, then they need to issue a separate cert for each primary domain that you could have come in on. Versus require star, they could just have one.
No, I guess I'm not understanding now, because what I was
Microphone.
Yeah, please.
Okay, so the situation is there's 10 different sites you can come in on. Yes. And Each one of those sites can have any of 1,000 secondary certs. So if you had star, then we would, as a CDN, you would only have to issue one hinge cert that would work no matter which one of those 10 you come in on. So each one of those you say require star, and it has cdn.com in the SAN. And then every one of the 1,000 certs that are, say, issued by the CDN have require cdn.com on them. So you can take any of those 1,000 sites, put them onto the hinge, and then put them onto one of the first 10. Does that make sense? No?
I think so, but I guess what I'm suggesting is, you do 2 secondary cert proofs.
Yes.
Okay, then I really don't understand what the require star does. Like, I'm confused because like,
We now have all the co-authors at the back microphone.
So you might arrive on any one of 1,000 certificates. In order to provision the cdn.com certificate, and in order for the client to add cdn.com to the set of names that the connection is good for, that certificate has to point to one that you already have in there, right? So A, B, C, D, E, F, G, that has to point to every single one of them. Start.
I mean, yes, you can certainly build the system that way, but like that's just because you've got like some mechanism you're overloading. Like, just treat the proof that you have the enabling cert as like a totally separate thing. What I'm suggesting is that basically that the thing you say requires has some like long ass like random name which doesn't affiliate with anything, which can't be isn't even an origin, right? And or can be an origin, but it's not an origin you actually serve data off of, right? And then you prove that you have that, and that doesn't suddenly enable the secondary cert. It's just hanging out, right? And all it's doing is enabling the other things. And they don't need require star, right?
So I think at this point we need to make sure we have an issue open that reflects this and drive it to resolution.
That's 522.
All right.
Servers can't detect attacks.
So we'll pursue it there, and I think we need to move on to the world of quick.
Most of the others are
HTTP
editorial.
integration.
Most of the others are editorial. I will mention that there is one issue that was opened by David Benjamin that I feel like doesn't really belong in secondary certs, and I told him to write a separate draft, and he has done so.
So we are behind on the agenda somewhat hopelessly, and there's a reason we organized the agenda with the adopted work first. It's flow control, if nothing else, for our ability to accept new work. So to anyone that isn't going to make it in today, you have my personal apologies, but that is the priority.
Okay, so this one is for an issue that we discussed at the quick interim in January. And we basically came to the conclusion that we think something needs to change, and it is too drastic a change for the quick working group to decide without the HTTP working group, so it got punted over here. And we are them, there's lots of overlap, but here's the place to discuss it. So the background for this issue. RFC 3986 defines URIs, and it says that URIs include a port. The type of the port is designated by the port number. TCP, UDP, SCTP is defined by the URI scheme. Okay, so next. Long time ago, we defined that the default port for HTTP over TLS is a TCP port 443. You can run HTTP over TLS over a different transport. We don't specify how that maps to a scheme. Next. In our most recent updates of the HTTP drafts, we say that if you use a different connection protocol, you would presumably use a different URI scheme, but we don't know what that would look like. And also, it is the authoritative interface for HTTP that is specific to TCP. All right, so HTTP and HTTPS are specific to TCP as defined. Next one. So for HTTPS specifically, we say that it's governed by a potential HTTP origin server listening on a given TCP port. TCP port 443 is the default. So where does that leave QUIC? HTTP 3, there is currently no defined way to refer to an HTTP 3 endpoint by URI, and if you have an HTTPS URI and you wanted to know that you can use H3 and go over QUIC, how do you get there and have an authoritative delegation? What constitutes authority? Next. So the first option, long live TCP. Right now we use alt service, so you have to connect over H2, get the alt service header or frame back, and then you have an alt service record that says in the future you can use H3, which goes over QUIC. Yay. Now we always have to have TCP, always and forever, until we find a way of getting an alt service record without going over a TCP connection first. Gives us the nice property that we can get a quick version hint along with the alt service record, but there are people who are unhappy about this, and understandably so. If you get an HTTPS URI, you'd kind of like to be able to use the latest version of HTTP to get to it, except we've currently defined that that's not an option. Next. So we've looked at various ways of mangling the URI to try and express this. I think it was Martin who referred to number 2 as a disaster of nuclear proportions in the other. So third option.
Please move on.
So third option, we just do dual stack. So 3986 says that the definition of the scheme defines what the transport protocol is. We're currently in the process of revising the documents that specify the scheme. 3986 doesn't technically say there can only be one. We could say that if you see an HTTPS URI, you're allowed to try both. Remember which one worked. They're co-authoritative. And what that would produce for us, next slide, is even happier eyeballs than we have right now. So, I mean, there are lots of considerations that we have to make here. Next slide.
You're a bad man, Michael.
I try. So, I mean, some of this is future looking. Will there ever be a QUIC only server that doesn't actually have a TCP endpoint? What does it mean for current servers that don't know or run QUIC, that somebody can listen on a UDP port, even a privileged one, and become co-authoritative with the process that thinks it's okay running on port 443? I know for us in our deployment, we're trying to carefully manage how much load is going to QUIC by only giving alt service advertisement out to a fraction of clients. And if clients are allowed to just willy-nilly connect to both sides, we lose that option. There are a lot of issues to be weighed here. And I think we need to make a decision about what is the right way to declare an H3 endpoint authoritative for a URI. Because right now, we have some arguments that H3, H2, co-authoritative, they're all the same content, versus you have to have an authoritative delegation, and the start of authority is that TCP point is defined. So let the spec lawyering begin.
So just one kind of clarifying question to the group as we're going through the line about what is the question to the group. I could kind of see it decomposed potentially into 2 separate parts. There's the first bit of saying, can HTTPS, like, will we allow that to be used for UDP? Because you could imagine a scheme in which out of band, like with alt-serve, you say, this is allowed to be quick, and then you just do it, even though the user typed in HTTPS. Yeah. And then there's the secondary mechanism of how do we signal that, which I think could be a much longer, broader tail of things.
So I was assuming that by defining alt service, we had already answered the first question as yes.
It may be good to just like confirm that with everyone.
Okay.
Because then that opens up a different field.
So before we get into the latter part of the discussion, is there anyone who would like to jump the queue and argue that only the TCP endpoint is authoritative at that URI and it cannot delegate to anyone else? And we were wrong in 7838. I'm seeing no one. Okay.
Gee, I'm just going to jump the queue based on the first half of that sentence, which makes me worried. Martin Thompson. So it turns out that HTTP kind of always aspired to being able to resolve different types of URIs. And so when we put an HTTPS URI into a quick connection, we're not doing anything more than that. The question that we need to ask ourselves is whether this is actually someone we should be sending that request to in the first place. I think this is really the question that we're asking ourselves here. If you think about the way that this is in the domain fronting scenarios that happened recently, it was possible to send, using any SNI, any connection to these servers, you could send a request for some resource on a different name. So you would connect on A, and then you would make a request for B. And it's also possible that you might, say, have a connection to one port, and then you make a request for a service that is ostensibly on another port. So we have all of these things are possible, and some of them are possible because attackers can change which TCP port number a request comes in on. This is not authenticated in any way. But the way that we deal with this is we have the host header field, which contains the client's understanding of who the request was directed towards. And the server can use this information, which is now authenticated, to determine whether or not it wants to answer the request. Now, obviously, all these servers can, all the servers on the same name can answer the request in the same way. The certificate is good for all of the different port numbers, and it also turns out that the certificate is good for the UDP port as much as it is for the TCP port by design, in fact. And so the only question that we really have to ask ourselves is whether we want to allow this. And the problem is that we sort of allowed it anyway accidentally because the host header field doesn't include the protocol. And so I'm going to suggest that the co-authoritative answer is the answer that we're looking for.
This is an important topic and a very long line. So if you would like to be heard, please get into it now and you will be accommodated.
Yeah. So I guess a couple observations. Abominable as those, various URI options you presented were, abominable is not actually the first problem. The first problem is any of those any one of those, that is not backward compatible with existing HTTPS URI is a non-starter because no sane person is put a URI as HTTPQ where nobody can dereference. So maybe you shove it in some query programs or something or some other place the parser doesn't know about, but it goes it's just not gonna work, right? So I suspect Anna will come kill me if we try to shove it somewhere in the query program. So I think that's basically they're all kind of non-starters. Maybe someone has a better idea than I do, but so I think we're kind of between so the real question is is it reasonable given HTTPS URI to just unilaterally try quick without any other indication that that's cool, right? And I guess I'm not here to like lawyer you about like what the specs actually say, because like we're allowed to do anything we want. We can just update the specs, like we have IETF consensus, et cetera, right? So I'm going to make, but however, I'm going to make two arguments. The first is that as a matter of like, you know, architectural philosophy, like the minute we decided like connection coalescence without like, you know, without DNS reference was like cool, we like gave up on the idea that like the host actually mattered, but anything other than the certificate actually mattered. And so the so the relevant thing, the relevant proof that you're willing to like willing to be this host is the fact that you have a certificate and with host name in it. And that is true, and that's just as true in Quick as it is in ordinary HTTPS over TLS. And in fact, it's the same source and it's the same like cryptographic protocol, right? So so from that perspective, I think like the natural answer really here is if you're going to HTTPS, like totally just try Quick, and like people who don't like want to support Quick, like you know, don't hit this more quick, and people don't want to support quick, and some of their only want to have partial quick to find some way to throttle and isn't all service. I mean, I guess I would say my expectation is that most clients are not going to happy eyeballs this for a while because there isn't any quick, and so it's a waste of energy to happy eyeballs. But at some point, when there's a lot of quick, then happy eyeballs make a lot of sense and people start doing it. So I suspect actually as a matter of throttling, you're probably pretty cool for a little while.
Ted Hardy, I'll try and be really quick. The number 2, we actually tried in the past doing this decoration for the late and much beloved IRIS protocol, which included a number of different transports, including the much lamented and dead beep. It was a disaster, not of nuclear proportions, because IRIS was never popular enough to be nuclear proportion, but it was an utter and complete disaster for the scope of the protocol it was involved with. Don't do that. It's horrible. Please stop. Don't. For option 3, I agree with most of what Ecker said. There's only one thing I would say here is there may at some point be some use for having a URI that tells you that something doesn't speak TCP and therefore it is not worth doing happy eyeballs to it. But I think that this is far enough in the future that you could alt service in the other direction if we've gotten to happy eyeballs there to say, hey, I'm going to start putting up quick and telling you that there's also a TCP, or not telling you that. So I really don't think there's any reason not to go for this as the baseline expectation. And I realize that it's not what the URI spec said, but having worked in the URI registration game for some time now, we moved from trying to make the spec gate how URIs worked to recognizing how people were actually deploy them over time, and I think this fits squarely in that change.
Queue is now closed.
Mark Nottingham. God. Go back to the 7230 text, please. Next one. Oh, jeez. Yeah, this is fine. So the word potential there is very important. It means that you don't actually have to go and make a TCP connection. It's just establishing authority for that URI. I don't think this needs to change. I disagree that we need to do number 3, because the only time we need to consider this is when we deprecate HTTP 1, HTTP 1.1, and HTTP 2, because they're all still running. They're all still establishing the authority. I don't think we're going to need this for the foreseeable future. It doesn't mean that you can't still happy eyeballs if you want to. And so, no, I can see, like Ted mentioned, a potential future where we establish a URI scheme for not browsers to use, but for example, if I want to configure an origin server for a CDN and I want to say that it's HTTP3, yeah, let's come up with a URI scheme, but let's put huge red warning lights around that it's not for use in the normal web. And there are a couple of ways you can do that. We can also see a future where we find a way to convey an alternate service in a DNS record, which I know that folks like yourself are interested in probably still. We can have those conversations, but I don't think we need to change this text.
Ian's back, Google. Can you go to the HTTP slide? Anyway, I think these are undeployable, right? Like no one's really going to do these. I would be
first one fails URI parsers.
I would be interested in either DNS or like a link, or embed attribute or some other web sort of thing that allows something similar to happen. But yeah, don't mutilate the URI. But yeah, everything else I agree with Eckers and others.
Igor Lubachev, Akamai. So I wanted us to think about the primary principle that we should be having, which is basically don't break the internet. And right now, and I don't want to be a protocol lawyer and try to figure out the meaning, what particular word to put more meaning on and less, but right now quick is very young. It's almost, well, some people can say it doesn't really yet exist, the implementations. And you'll have operators who are trying to try it out, and they will try to roll it out. They will want to be able to control how they roll it out, because they will know there are bugs, performance problems, interrupt problems, and potentially load on the infrastructure problems. So whatever we want to do here, we shouldn't just say, let it happy eyeball right now. And, or if we want to do it, the client shouldn't implement it, because the eyeballs will definitely be not happy.
Just in the interest of saving, thank you. In the interest of saving time, if folks are in line to argue against those options, it's not necessary. We get it, I think.
So I'll avoid talking about. I'll avoid talking about the happy eyeballs one, which I would +1 to the risks there. But I think for these two cases, I think there's a normal case and there's the custom client case. I think for the custom client case where the client and server really want to use Quick for something and only support Quick, I think that might be worth separately looking at that class of problems along with like maybe over in TAPS or someplace similar of like, how do we want to configure up these things? Because it's not just Quick, it's probably a set of transport parameters. And you look, Mark mentioned the configuring a CDN origin. There are a lot of other parameter factors. Trying to cram all those into a URI is just not going to work. So that might be a class of things worth thinking of it on its own. I think for the kind of web case with airports or web, I think DNS is an area where we may want to start looking at it. And I think there's a bunch of areas around right now, and like on DNS op, there's a mail probably once a month of people saying, why don't those damn HTTP people use SRV records or make their life easier? It may be that between ESNI keys, the A-name stuff, Roy has a HTTP record draft, that Mike's alt service draft, time to really take a step back and say, what are all the things we want in a HTTP or HTTPS DNS record that solve a few of these problems, and just do that in a way that we can kind of get this sort of negotiation there rather than try to piecemeal it together.
Hi, Lucas Pardew. So the alt service options, one of the potential ways you might want to deploy this is to have a kind of matchmaking or broker service. So something listening on TCP that's intended to design hand off to different quick endpoints. But the question of load is really interesting in this perspective, because although it should be fully authoritative and answer to everything, it doesn't want to. And so scaling of these things, where we want Quick to handle most traffic and not have something scaled to handle TCP traffic at those levels, is difficult. And so those options with DNS are quite interesting, because if you never hit an origin at TCP, and if you do hit an origin with TCP and quickly go over to Quick, we need to think about the fallback story and whether clients, what they do there. If they have nothing to fall back to because they got an answer from DNS, to me that seems like a better way to transition into this Quick future.
Roy Fielding. So my understanding is that this is about the situation where you want to do Quick first and you haven't been told already that Quick is available. So in all of the other cases don't matter, because you could get information otherwise. RFC 3986 is deliberately intended to allow this. It is a mapping from identifiers to delegated naming authorities. It's not an instruction to go use HTTP on TCP port 80, whatever, blah, blah, blah. It's not. That's not what it says. It deliberately allows this, option 3. And this is in HTTP core. We have an issue 194, which is currently discussing this.
Yes. That was created after the interim.
Right. So we should refer to that when talking about. And for me, the only thing that really matters is whether the result, whatever we do, is consistent with the social requirements of HTTPS, which is that the communication be authenticated with the intended authority before you start sending requests, and encrypted with that authority. And near as I can tell, after the discussion we had with Martin earlier, that's sufficient and only sufficient to rely on the certificate that's provided. So we're left with the decision. It's like, well, if a site has a certificate and they claim to be a secure site, they have to maintain control over their UDP port if they have a TCP server on HTTPS. And that, I think, is a social host requirement that the IETF would impose, not a technical issue.
Eric Kinnear, Apple. I would reiterate that I have a very strong interest in being able to just up and connect without having another source of information. But that being said, when other sources of information are available, definitely planning on using them and doing that. And in the interest of keeping this short, I will mostly just agree with what Ecker said, in that the incentive structure is already correct for doing kind of the right thing here, as Quick becomes not super available to very equally available to maybe even mostly available.
Timur Gavrichenkov, Curator Labs. With regards to the option 3, I want to point out that for a decade already, a huge and unexpected amount of UDP packets of almost an MTU size coming to the port 443 was always a good sign of a DDoS attack. And it's actually used as a detection method. So I believe the option 3 heavily violates the principle of least surprise and can cause some potential false positives in real life.
I think that's Scott. I think that's an interesting point and something we should definitely
The queue's closed.
do more thinking.
Gabriel, the queue's closed.
Okay, I'll send it on
Yeah.
the Travis.
Okay. Yeah. Thank you, Michael. This is interesting discussion. So I'm up next. You are. I'm going to make it incredibly. I'm going to go Ecker speed. Let's go. Proxy status, news draft, next slide. Squid gives proxy errors in this format. Next slide. Fastly has documentation about how to get proxy errors in this format. Next slide. This is how Cloudflare does it using HTTP status codes. Go Cloudflare. Taking them all. Next slide. I'm not going to talk about how bad that is because I love my fellow colleagues. Next slide. This is how it is done in, this is Google Cloud. Thank you. Next slide. And this was so I wrote up some stuff. I saw this, and I'm working on how to make interfacing with CDNs and reverse proxies more normal. And then I came across this, which was by Peter. Hi, Peter. Who wrote how to do this for Envoy. And we started talking, and he came on as a co-author, and we came up with, next slide, this draft, which is, Right. Let me go Ecker speed. Come on. So we came up with a spec. Next slide. These are some examples. It's a response header that a proxy of some intermediary, excuse me, can put onto responses to explain why it generated an error response or otherwise adorn the response, even if it's successful from the origin. It's still in progress. We still have a few open issues against it, but I've talked to a few people about it. It seems like people like the idea of doing things one way instead of 15 different ways. And so next slide, I'm asking, is this interesting and do we want to adopt it?
Alessandro, Cloudflare. I'm not going to propose to rename this, don't worry. We have some uses for this, as you mentioned. That was one of those. So I'm interested in working on this and also adopting.
Okay. I don't want to spend a lot of time because I'm very conscious we have a lot of other folks. Can we just take a call adoption to the list or something? Or
did you want to hum?
Sure, if you're going to do it real quick.
Sure. Yeah.
Quick
Right?
comment?
Sure.
Well, now that you just displayed that, and I didn't see it before, then you definitely want to make that cache status on the other side.
Yeah, that's what this is what I was referring to. Yeah, okay. We'll have that conversation, sure.
All right, so it seems pretty clear we have interest. Just to get a sense of the room for adopting, let's do a quick hum on that. If you would like to adopt this work, please hum now. You have a microphone. No humming into the microphone. If you would not like to adopt this work, please hum now. Okay, that sounds good. We'll confirm on the list. Thank you.
We got time. We have time for one more left in our show today. So the update on HTTP2 as a transport from Eric Kinnear. Yeah, if you take if you take Mark's lead, we can hear a little bit about stateful compression.
What? There we go. Works great. All right. All right, super lightning speed. I'm Eric. Ooh, this microphone is great. I'm Eric Kinnear from Apple. We talked about this a little bit in Bangkok, and it looked very, very different then. So thank you for all the feedback, because some of that's been incorporated and some of that is pending on being incorporated. So there are several gaping holes here that we will totally fill in. We talked about this in TSVWG, so you can go watch that if you want more details, which is going to make us go even faster right now. But effectively, we're trying to do a bunch of stuff that lets us use H2 to share multiple streams that would otherwise be separate transport connections. So we want that all on one transport connection. And that brings some interesting benefits, like you've already got this connection up, and so you have this nice security context that's already established, and you can just make new streams over it, and everybody's happy. But there's also some issues with that, like you now introduced head of line blocking, and if you're going to be doing UDP and datagram transport, you've got all sorts of fun MTU questions, et cetera, et cetera. And that sparked the wonderful thought of, ooh, this is yet another way to tunnel things in TSVWG, which brings in a whole set of considerations on what happens when you tunnel things and you put congestion control inside congestion control, and what could you possibly shoot yourself in the foot with. So we asked them kind of, where does some of this work belong, and especially in the newer form that is very HTTP specific, because the definition of how to do this is very HTTP specific. They said it's something that should probably be covered by Httpbis, but at the same time, please do continue discussing it in TSVWG, especially around some of the tunneling and transport considerations versus the specific header and protocol field values that the spec defines. So that's the update from TSVWG. In lightning speed, we want to do this because we're sharing underlying transport stuff. Yay. HTTP2 is great because it gives us a lot of what we want. And we've got this nice connect thing that you can use to talk through the server to some other endpoint. And that WebSockets has this extended connect thing that lets you talk just directly to the server and open streams in parallel with your other requests and responses. You can bike shed wire formats for framing to add UDP, and that's very exciting. And you've got these nice headers that you can add other things to. So like WebSockets defines some custom headers that help you negotiate WebSockets. This allows you to add that to any of these requests to talk about what the next protocol will be, et cetera, et cetera. The document itself defines two new protocol values for the extended connect handshake, one of which is byte stream, one of which is datagram. Byte stream gives you a new stream. So when you send this to the server saying my protocol is going to be byte stream, plus presumably some way to know what's going to be used on that, you now have another stream that's in parallel with your other requests and responses, but is just a byte stream. For datagram, toss in some framing, you've got UDP, it goes through. There's some concerns that have already been raised on the list. Thank you for those. We should chat about those. Can I get the next slide? Apparently.
I moved my mouse.
Oh, how could you? Yay, thank you. So this covers 90% of what we want, and a lot of really interesting use cases that we've been talking about with various people, and we can talk about those more in detail later, or if you have another use case, come find me and I'd love to chat. But the one that we haven't talked about yet is Quick, and since we need Quick in every presentation, we're going to talk about Quick Transport. So HTTP3 over Quick Transport talks to HTTP2 over TLS TCP when Quick is not available, but we need to know what Quick Transport is going to do if there's no HTTP3 on top. H2 gives you a lot of the same things that Quick do as the framing layer separate from the HTTP layer. Some of that admittedly is coming from TLS and TCP, like retransmitting losses and things. So we make a new setting to say, hey, I can send the extended connect in another direction to open a stream from the server to the client. And if you do that and write some other text about exactly the mapping of frame to frame, this is one way, and I'm sure there are a great many others in which you can use this to run protocols that would run on Quick Transport over here. So in summary, we add some new protocol values. We add another setting to do it in both directions for the people who want that, and yay.
So Alan, we're actually going to not take questions on this one. Just trying to get another one in.
But let's chat.
Yeah, absolutely. Thank you for the presentation. This is great work, and I want to continue to see it, just discovered in our space. Felix, stateful compression, an oldie but a goodie. You get our last 5 minutes.
It's back. Is this the clip here? All right, we'll just do slides. Cool. Hi, I'm Felix. I'm going to try to do this in like 2 minutes. Next slide. I work on Z-Standard at Facebook. Next slide. I want to talk about improving HTTP response body compression, in particular for small responses using an external dictionary. Next slide. Basically, compression sucks on small values. Next slide. Using an external dictionary can make compression better, especially for small values. Next slide. There are lots of possible places you could get this external data, some of which already exists that you're already handling. Other ways would be dedicated data that you prepare for this purpose. Next slide. There have been a lot of proposals in the past that explore these different ways to source data and use it. Next slide. They have all sort of met various demises. There are some challenges in this space. Anytime you're dealing with state, things get more complicated, but particularly in this space, there are security challenges. Next slide. Sorry, next slide. Yeah. Compression in general in HTTP is a security challenge. I think we all know this, and it's sort of an open topic in some ways. Next slide. We are working on exploring, Murray and I should say, are working on exploring the security challenges as they pertain to the use of dictionaries for compression. We hope to have this draft adopted by the working group. At some point, I think there's more work we need to do before that happens. Next slide. And then the other thing, I am working at Facebook to deploy a dictionary-based compression system to our traffic between our infrastructure and our mobile apps. We're starting with a static dedicated dictionary. We hope to evolve beyond that, and we hope to do this in a way that will reconcile with some future standardized way to do this that could be implemented broadly. We expect to see these improvements. Next slide. So in conclusion, we're looking for interested collaborators, implementers, browsers in particular. We want to talk about what it would mean to ship something like this. Next slide. Thanks.
Thank you, Felix. Brian Sniffen, make your way to the front, please. I think that last presentation is important. We've been asking for this sort of level of detail for a while. There's a lot of interest in this area, so please do continue that work. People, please read the draft, and we'll hopefully see that again soon. Brian, go.
You should read the draft. Next slide. Right now, CDNs, all of them end up getting pressured by their customers to separate the world into a place where everybody can see, and some organizations can maybe shame people like news sites that were only using HTTP into using TLS. But then the browsers talk to the CDN goes forward to the origin, and an alarming number of origins from sites that might terrify you if you knew insist on using non-TLS for the CDN back to origin connection. Next slide, please. So we've proposed for a while standardizing some way for the CDNs to expose to the front to where everyone can see what's going on behind. Is this for browsers to consume? Next slide. No, it's not. Because if the browsers block this, the customers are just going to push on lie in this header that I'm proposing you standardize. So that doesn't help anything, right? Getting this adopted requires the browsers to wait until the tiger is well and fully into the box before we shut the door. But there are a number of organizations that have put together fantastic dashboards to use public opprobrium to push the state-of-the-art forward for this. And that's what I want to enable with Fastly, with Cloudflare, with Akamai. Next slide. How do you use it? It's a header. You use it like this. Original versions of this look something like the top one, where maybe you say, by the way, my customer's doing something naughty. Asking the CDNs to do that, maybe that works. We're going to try that, but maybe there's too much pressure to say from the customer to say, don't advertise that I'm doing something naughty, omit the header, and a silent signal looks like good behavior. That's not so great. On the other hand, we're moving into a world between perfect forward secrecy and post-quantum crypto, where we can advertise that the protocol to the origin and the background protocols inside these complex CDNs and multi-host networks has particular good features, and it's a lot easier to resist pressure to lie by commission instead of resisting pressure to lie by omission. So we're at a unusually useful point to introduce a header like this and try to push some of these origins to support non-plain text communications backwards. Next slide. It's also an opportunity to write down what's actually safe versus not. Maybe there's some things that you can do to be less bad while acknowledging that you're sinning horribly as you do this. That's all I've got. I'd love to talk to other CDNs about how to do this. And if there's a browser who thinks that they're just going to have to ship something that red flags this as soon as I put that header there, let me know now so I can save my time. Thank you very much.
Brian, are you asking the working group to adopt this now or soon or?
Yes, please.
Okay. Who's read the draft? Show of hands. Who's read the draft? Okay. What do we think? Do we want to hum now or take it to the list? A little
Minimal.
A hum is not an official action. We'll take it to the list, I think.
Thanks.
That sounds good. Thank you very much. And apologies to Jeffrey Yaskin. You're the only one we didn't get to.
Dispatch video.
Yeah, there was a dispatch video and there was also a side session. So hopefully folks had a chance to get that. Thank you all. We will hopefully see you in Montreal.
So hard. We got through almost.
We do the best we can. Sometimes the authors don't get into it.
So they are on the GitHub. You're looking at GitHub, not the data tracker. So they're all there, and they have been there. They're all here before the session on the
Hum is totally official action, my friend.
Sorry?
Hum is totally official action, my friend.
What is?
Hum is